NASA astronaut Tracy Dyson and her companions are safely on their way to the International Space Station, ISS. The trio, consisting of Dyson, Roscosmos cosmonaut Oleg Novitsky, and spaceflight participant Marina Vasilevskaya of Belarus, embarked on their journey from the Baikonur Cosmodrome in Kazakhstan. Their Soyuz Ms-25 spacecraft docked with the space station's Prikul module around on March 25. Upon opening the hatches between the station and the Soyuz, the team will join the current crew, which includes NASA astronauts Laurel Lahara, Matthew Dominic, Mike Barrett, and Jeanette Epps, as well as Roscosmos cosmonauts Oleg Kononenko, Nikolai Chubb, and Alexander Grebenkin. Novitsky and Vasilevskaya are scheduled to stay aboard the station for 12 days before returning to Earth with Lahara on Saturday, April 6, aboard Soyuz Ms-24. Dyson, on the other hand, will remain on the ISS for 6 months as an Expedition 70 and 71 flight engineer, returning to Earth in September alongside Roscosmos cosmonauts Oleg Kononenko and Nikolai Chubb, who will complete a year-long mission on the laboratory. This mission marks Dyson's third spaceflight, Novitsky's fourth, and Vasilevskaya's first. A complete solar eclipse offers breathtaking celestial vistas to observers within the path of the Moon's shadow. This cosmic phenomenon not only provides scientists with a unique opportunity to study the Sun and its effects on Earth, but also presents an ideal chance to immortalize unforgettable moments through photography. Whether you're an amateur shutterbug or a seasoned selfie aficionado, consider these pointers for photographing the eclipse. Number 1. Prioritize safety. Directly viewing the Sun poses risks to both your eyes and your camera equipment. To photograph the Sun during partial eclipses, it's essential to employ a specialized solar filter to safeguard your camera, just as you would use solar viewing glasses, also known as eclipse glasses, to protect your eyes. However, during totality, when the Moon completely obscures the Sun, remember to remove the filter to witness the Sun's outer atmosphere, the corona. Number 2. Every camera counts. The ability to capture stunning images during the eclipse relies more on the photographer's skill than the equipment. Whether equipped with a high-end DSLR or a smartphone camera, you can seize remarkable photos during the eclipse. Remember, the most crucial assets are a keen eye and a clear vision of the desired image. If you lack a telephoto zoom lens, focus on capturing panoramic shots to document the evolving surroundings. Employing additional equipment can prove advantageous during the eclipse. Utilizing a tripod aids in stabilizing the camera, reducing the risk of capturing blurry images in low-light conditions. Moreover, employing a delayed shutter release timer enables you to snap photos without inadvertently shaking the camera. Number 3. Explore every angle. While the Sun commands attention during a solar eclipse, don't overlook your surroundings. As the Moon traverses in front of the Sun, the landscape undergoes a transformation, bathed in an eerie luminance with peculiar shadows. Natural pinholes formed by overlapping tree leaves project miniature eclipse replicas onto the ground. Every direction offers the potential for exceptional imagery, so experiment with wide-angle shots to encapsulate your eclipse encounter. Renowned NASA photographer Bill Ingalls suggests focusing on the human aspect of witnessing the eclipse. The most compelling images will capture the reactions of those around you, pointing, gazing, and marveling at the spectacle, Ingalls emphasized. These moments authentically convey the emotional essence of the event. Number 4. Hone your skills. Familiarize yourself with your camera's capabilities before eclipse day dawns. Most cameras, including some smartphones, feature adjustable exposure settings, allowing you to adapt to the eclipse's challenging lighting conditions. Master the manual focusing function of your camera to ensure crisp, clear shots. For DSLR cameras, determining the correct exposure necessitates pre-eclipse experimentation. Using a fixed aperture ranging from f8 to f16, test various shutter speeds between 1 to 1000 to a quarter second to determine the optimal settings for capturing images during partial eclipses. During totality, when the corona exhibits varying brightness levels, maintain a fixed aperture and experiment with exposure times ranging from approximately 1/1000 to 1 second. Number 5. Share your experience. After the eclipse concludes, share your photographic journey with friends and family. Tag at NASA on social media to connect your photos with others captured across the country and share them with NASA. While you focus on capturing those eclipse snapshots, take a moment to savor the spectacle firsthand. Remember to wear your solar viewing glasses, or eclipse glasses, throughout all stages of the eclipse, from start to finish, to protect your eyes. Preparations are underway for the crew flight test mission, slated for early May. Boeing has commenced the fueling process for its Starliner capsule in anticipation of the vehicle's maiden voyage with astronauts aboard. The crew flight test (CFT) mission is set to lift off in early May atop a United Launch Alliance Atlas V rocket from Cape Canaveral Space Force Station along Florida's Atlantic coast. It aims to ferry NASA astronauts Suni Williams and Butch Wilmore to the International Space Station (ISS) for a mission lasting approximately 10 days. On Monday, March 18th, Boeing revealed a significant milestone on the path to launch: the commencement of propellant loading into Starliner. An operation expected to span about 2 weeks, this operation is being carried out at Boeing's Commercial Crew and Cargo Processing Facility, C3PF, situated at NASA's Kennedy Space Center, adjacent to Cape Canaveral Space Force Station. Boeing stated in a brief update on Monday, the propellant loading operation is managed by a team of specially trained technicians, fluids, propellant, and electrical test engineers. Throughout the process, test team members closely monitor the spacecraft, including its sensors, valves, and the environmental conditions within the C3PF. They added, in September 2014, NASA awarded Boeing and SpaceX contracts worth billions under its Commercial Crew program. While SpaceX has successfully conducted 8 operational astronaut missions to the ISS for NASA, along with 1 crewed test flight, Boeing Starliner is yet to transport crew members. Starliner has been launched twice on uncrewed test flights to the ISS. The first mission in December 2019 encountered several issues, failing to dock with the ISS as planned. However, the second attempt in May 2022 proved successful. Originally scheduled for launch last summer, CFT has faced multiple delays due to technical challenges, notably issues with the suspension lines on Starliner's main parachutes and the presence of flammable tape around much of its wiring. These issues have since been addressed by technicians, and CFT is now slated for liftoff this spring, according to NASA and Boeing officials. Saturn's moon Enceladus has long intrigued scientists with its icy exterior concealing a potentially habitable subsurface ocean. Now, ESA, European Space Agency, is poised to embark on a groundbreaking mission to uncover the mysteries hidden within this enigmatic moon. This decision follows extensive deliberation by a team of experts tasked with shaping ESA's future endeavors in planetary exploration. Enceladus, a small moon orbiting Saturn, has captured the imagination of astronomers and astrobiologists alike. Beneath its pristine, frozen shell lies a vast ocean believed to harbor the ingredients necessary for life: liquid water, a source of energy, and a unique chemical composition. Plumes of water vapor and icy particles erupt from the moon's surface, hinting at the dynamic processes unfolding beneath the icy crust. ESA's proposed mission to Enceladus represents a bold leap forward in our quest to understand the potential for life beyond Earth. Scheduled for launch in the early 2040s, this mission will utilize cutting-edge technology to study Enceladus's subsurface ocean and search for signs of microbial life. The decision to prioritize Enceladus was informed by a thorough analysis of scientific objectives, technical feasibility, and potential for groundbreaking discoveries. ESA's team of scientists and engineers meticulously evaluated various candidate moons, including Jupiter's Europa and Saturn's Titan, before ultimately selecting Enceladus as the primary target. The mission will build upon the success of previous endeavors, such as ESA's Jupiter Icy Moons Explorer, JUICE, and the joint NASA, ESA, ACI Cassini-Huygens mission to Saturn. Armed with state-of-the-art instrumentation, the spacecraft will embark on a journey of exploration, traversing the vast expanse of space to reach its destination. Upon arrival at Enceladus, the spacecraft will conduct a comprehensive study of the moon's surface and subsurface environment. Specialized instruments will analyze the composition of the plumes emanating from the surface, providing valuable insights into the moon's geology and potential habitability. One of the mission's primary objectives is to search for biosignatures, evidence of past or present microbial life. By collecting samples from the plumes and analyzing them onboard the spacecraft, scientists hope to uncover clues about the potential existence of life beneath Enceladus's icy exterior. ESA's mission to Enceladus represents a significant milestone in our ongoing exploration of the solar system. It underscores Europe's commitment to pushing the boundaries of scientific knowledge and unlocking the secrets of our cosmic neighborhood. As humanity ventures further into the cosmos, missions like this serve as a testament to our insatiable curiosity and our collective desire to unravel the mysteries of the universe. ESA's quest to explore Enceladus is not just a scientific endeavor, it is a testament to the human spirit of exploration and discovery. ESA's Gaia Space Telescope has delved deeper into the annals of our galaxy's past, revealing two unexpected streams of stars that intertwined over 12 billion years ago. Dubbed Shakti and Shiva, these two streams played pivotal roles in the infancy of the Milky Way, predating even its oldest spiral arms and disk, Koti Malhan, leading the research at the Max Planck Institute for Astronomy, MPIA, in Heidelberg, Germany, expressed astonishment at the clarity with which these ancient structures could be discerned. She credited Gaia's unprecedented data for this breakthrough, enabling the identification of these ancient star groups, despite the significant evolution of the Milky Way since their formation. Using Gaia's observations, researchers traced the orbits, composition, and content of individual stars within the Milky Way. The distinct orbits and chemical compositions of stars within Shakti and Shiva stood out amidst the galactic ensemble, leading to their identification. Each stream harbors the mass equivalent of approximately 10 million suns, comprising stars aged between 12 and 13 billion years, all moving along similar orbits with comparable compositions. Their distribution hints at their origins as distinct fragments merging with the nascent Milky Way, situated towards the galactic core. Both streams were explored by Gaia in 2022, unveiling a region teeming with the galaxy's oldest stars. Born before the formation of the Milky Way's disk, co-author Hans Walter Rix likened this ancient region to the poor old heart of the Milky Way due to its scarcity of heavy metal elements. Shakti and Shiva, while akin, exhibit subtle differences. Shakti stars orbit slightly farther from the galactic center in more circular paths compared to Shiva stars. Reflecting their intertwined nature, the streams draw inspiration from Hindu mythology, named after a divine couple credited with the creation of the universe. The discovery of Shakti and Shiva marks a significant stride in unraveling the Milky Way's complex family tree, shedding light on its earliest growth stages. Future Gaia data releases hold the promise of uncovering more components integral to our galaxy's formation. Koti and Hans Walter's dynamical map, constructed using Gaia data, charts various components that shape the Milky Way, including Gaia Sausage Enceladus, LMS-1 A Wukong, Arjuna Sequoia Phi-Itwa, and Pontus. These revelations contribute to Gaia's overarching mission of elucidating our galaxy's infancy and evolution, painting a more comprehensive picture of our cosmic origins.